Good morning. This is Robert Molleda. I'm the warning coordination meteorologist at the National Weather Service in Miami. And this is the winter dry season outlook for South Florida for 2020 and 21. We're happy to be collaborating once again this year with the South Florida Water Management District. And I've been doing this for several years in a row now, and we're certainly very happy to do this. After my presentation, Akin Owosina from the South Florida Water Management District will then give the perspective from the district side of things as far as water levels and other related topics. But first of all, we start out the presentation here. We go to the next slide. We'll do a recap of the rainy season, which ended on October 15th, although really the rainy season or the rainy pattern is continuing, even though the technically the season ended back on the 15th of October. We still really haven't gotten to that transition yet, where we transition from the rainy season over to the dry season. But as far as what we observed during the wet season, May 15th to October 15th, we started out really very wet after a pretty dry spring earlier this year. The first 2 weeks of the wet season, which are the last 2 weeks of May, were quite wet. In fact, many areas, especially in Southeast Florida, had well over 10 inches of rain just for that 2-week period alone. And that was as a result of a couple of tropical disturbances, one of them being the disturbance that eventually became Arthur, the first storm of the season way back in May. So we had some flooding issues as a result of that copious rainfall over a very short time period. Then after that, we kind of went into a relatively dry period, June and really part of July as well. And actually it was dry enough that we ended up with abnormally dry conditions that developed over parts of Southwest Florida. Then when we got into August, we still ended up a little bit on the dry side, although maybe not as dry as it was in June and July. We did have some indirect tropical impacts from tropical storms Isaias and Laura, but they were indirect and the rainfall really wasn't, we didn't really get a lot of rainfall, at least on a area-wide perspective, from either of those systems. But then once we got into September, then a wetter pattern certainly began across most, really not all of the area, and that pattern has continued here into October. We had Tropical Storm Sally towards the middle of September, as well as a couple of weak fronts that just kind of stalled over South Florida, and those resulted in quite a bit of rainfall and above normal rainfall for most of the area for the last basically 6 weeks or so of the wet season. So all in all, Fort Lauderdale, for example, ended up with the third wettest rainy season on record. So in balance, we ended up with above normal rainfall for most areas, and we'll talk a little bit more about that in the next few slides. It was also the 7th wettest at Miami International Airport. However, it wasn't wet everywhere, or it wasn't wetter than normal everywhere. Over in Naples, for example, Naples had the 17th driest dry season. I'm sorry, 17th driest wet season on record. Again, kind of an example of how some areas near the Gulf Coast actually were drier than normal. Didn't get as much rain as areas farther to the east. If you go to the next slide, we'll see some examples of some rainfall totals from some National Weather Service sites. And compared to normal, you see the numbers really stand out, the higher numbers. For example, Juno Beach had almost 66 inches of rain for the wet season. That's almost 30 inches above normal. Fort Lauderdale Airport, 60 inches of rain, 22 inches above normal. Many areas were at least 10 inches above normal, recorded anywhere from 45 to 60 inches of rain. And again, those values were mainly over in the southeast part of the peninsula, or eastern half of South Florida, basically. But as I said before, there were other areas, especially there were parts of the Everglades and especially towards the Gulf Coast where rainfall was certainly not as much, or at least there were spots of dry conditions, and that is exemplified by Naples. Naples Municipal Airport was actually almost 4 inches below normal for the wet season. Good. If you go to the next slide, now we're going to go month to month to to kind of just give you a summary of what the rainfall from an area-wide perspective. So as I mentioned previously, in May we started out. The rainy season did start on time, and it started with a bang, with many areas receiving over 10 inches of rain for that 2-week period, basically from about May 15th through about May 29th. So again, a lot of rainfall. Virtually the entire area had above normal rainfall for that time frame. Okay, and we go to the next slide. June was a little bit drier, as you see there, mainly in the yellow and orange. I'm sorry, yellow and green, which are near to slightly below normal. Okay, next slide will be July. This is where we got a little bit wet again. Well, eastern areas were wet, but you notice how it stayed kind of dry along the Gulf Coast and western areas. They actually were briefly in abnormally dry, or what we call pre-drought conditions, for a few weeks there in late July, early August. That kind of relative drying trend continued in August. If we go to the next slide, we didn't really have any direct impacts from the systems that were near us, Isaias and Laura. Now we'll go to the next slide, September. Then that's when the wet pattern began, or restarted in earnest. We had the impacts from Tropical Storm Sally, which dumped over 10 inches of rain over some areas. And we also had a couple of very weak early season fronts that just never really made it through, but just close enough to us to give us some enhanced rainfall. And then finally, October, go to the next slide. The wet pattern continued, and this only goes through October 16th, well, basically through the last day of the rainy season. If we showed this all the way through today, you would see even higher numbers. Some areas in the last week have had over 10 inches of rain, mainly over southeast Florida, which, if you look at the entire dry season average, some areas are getting close to half of the total dry season normal rainfall, which is pretty remarkable. But that's something that can happen, especially during the early and latter stages of these seasons. A lot of times, or many times, there are transition periods. Even though we define start and end dates, whatever date we define, very rarely is it a clean start or clean end. There's going to be a transition period, and sometimes these transition periods can be pretty messy, pretty like what's going on with the end of the rainy season, beginning of the dry season. All right, so let's go ahead and talk about the outlook. So we went over the rainy season. So let's go to the next slide. And these are the winter outlook graphics that the Climate Prediction Center put out 2 weeks ago. So I'm sure most of you have seen this. And it's showing for temperature, at least. Again, this is what they define as a winter outlook, which is December, January, and February. And you see basically the entire southern half of the continental United States, and even up into across the eastern U.S., likelihood of above normal temperatures. And this is really a similar pattern that's projected for the entire duration of the dry season. So if I were to break it down for each month of the dry season, it would look a lot like this one. So I'm not going to go through each one of those. This winter outlook is pretty representative of the outlook for the other months. So we're kind of somewhere in that 50 to 60% probability of warmer than normal conditions. All right, let's go to the next slide. So the next slide will be the precipitation outlook for the same time frame. And the southern tier has an increased likelihood of being drier than normal. And actual probabilities for that are about similar to the temperature, about 50 to 60%, but on the dry side as far as precipitation is concerned. So again, this is a similar pattern that we project for the duration of the dry season, all the way from basically November through April. Okay, next slide, please. So the factors that are contributing, like pretty much every winter, the number one thing we look at is the phase of the ENSO, the El Nino Southern Oscillation. And so this year, we're already starting the La Nina phase or La Nina conditions. And the likelihood is that the La Nina pattern will continue all the way through spring 2021, basically through the dry season. So that's probably the main factor, but there's a couple other ones as well. We also look at the trends. In other words, what the previous winters, previous seasons, how they've ended up from a precipitation and temperature standpoint. And then we also look at some models, some weather models, dynamical as well as statistical. Okay, next slide, please. So just a little primer, I guess, on La Nina. La Nina, as I mentioned already, is part of what we call the El Nino Southern Oscillation, along with its counterpart El Nino. And basically, these are cyclical temperature changes in the tropical Pacific Ocean. It's their naturally occurring phenomena. They occur about every 3 to 7 years on average. So, for example, the last La Nina was in 2017, 2018. So that's actually pretty much on schedule, about 3 years ago. And so these are interactions between the ocean surface and the temperature changes in the ocean surface in the Pacific Ocean, and then the atmosphere. The atmosphere and the ocean, they're connected. So whatever changes occur in either will affect both. So these changes in the ocean surface temperatures affect tropical rainfall patterns and winds over the Pacific Ocean, which in turn then impact the ocean temperatures and currents, and then that in turn begins to affect or modify, if you will, weather patterns across really the entire globe. So it's not just a Pacific phenomena; it actually the impacts are felt, all over the globe. So we know in order for a La Nina event, like in this case, for example, to be ongoing, we need to make sure it's not, in other words, we just don't look at the ocean temperature. We want to make sure that there's what we call atmospheric coupling. In other words, that the atmosphere is responding to these changes in a pattern that we've seen or that we consider typical for La Nina. And we've already started to see that. So the Climate Prediction Center went ahead, I think it was about a month ago, they went ahead and started what they call a La Nina advisory, indicating that the conditions are already in place and that they're expected to continue throughout the rest of the winter and dry season for us. Okay, so this is, I'm gonna skip this one here. Okay, you can advance 2 slides. So you can skip the next one. All right, so you advance the slide, then I'll tell you where to go. Sorry about that. Okay, go to the next one. Okay, you can go to the slide that says current and forecast ENSO conditions. That's what the title should read. There you go, perfect, that's the one. So here, you see is the image on the left is an animation basically of the temperature, sea surface temperature departures from normal over the Pacific Ocean. So we're looking at the Pacific Ocean, the tropical Pacific, all the way from South America, Central America, Mexico, all the way over to the Western Pacific. So you see the blue colors are expanding there from east to west. That's a hallmark of La Nina. So, and then on the right are the probabilities, based on different models of which phase we're going to be in, La Nina, El Nino, or neutral. And the blue bars are the probability of being in La Nina condition. So you can see all the way through the February, March, April timeframe, we're at least 60%, and actually right now we're at 90% for the next 3 months here. So again, it means that we're likely that for the or it is likely that the La Nina conditions will continue all the way, definitely through, certainly more likely through the winter and then through the spring months as well. And then these are actually what individual models are showing regarding the temperature departure of the ocean temperature departure from normal. And so basically what we're seeing here are, again, what different models are showing. And if you advance the slide one more, or if you just click advance, the animation will pop up. You'll see a line that'll come across there. That line is sort of the divider between what we consider El Nino and neutral conditions. So anything below the blue line is La Nina. Anything above is neutral or El Nino. So you see everything, almost every line, every model is below the blue line. So almost every model is showing La Nina conditions, and many of them are showing getting it into a moderate range, and even a few getting into the strong range. So, we'll talk a little bit more about that as well. So given that there's a high likelihood of La Nina conditions, these are, and we talked earlier about how the La Nina modifies weather patterns across the globe. This is, again, in a very general sense, for North America, kind of what it represents. So what we see here is a jet stream that tends to be farther north. That means that the storm tracks, so that the jet stream largely dictates the storm tracks, that we see during the winter for progressing from west to east. And the jet stream being farther north, the storm tracks have a tendency to stay farther north. Not that it's going to do that for every single time, but again, this is kind of an average of what we typically see during a winter season where we have La Nina in place. So with the jet stream being farther north, not only are the storm tracks farther north, for the most part, also there's an increased tendency for the cold Arctic air to also stay to the north. So the end result, especially for the southern tier of the US, is for drier conditions due to the storm track staying farther north, and also warmer than normal conditions due to the cold air staying more to the north. So again, this next slide pretty much describes what I just talked about. So the jet stream farther north, winter storm tracks also stay to the wall to the north of Florida for the most part, not always. So with the fronts, with the low pressure areas having a tendency to stay well to our north, that means that there's usually less moisture and atmospheric instability in association with these fronts when they do make it down to Florida during this type of pattern. So that tends to result in a less stormy, less rainy pattern during the cool months. And just to remember that La Nina sets the stage for these patterns to occur. It's not a direct cause. So I think it's an important distinction to make. So go to the next slide. If we go back and look at previous La Nina events and also looking at previous El Nino events and say, okay, as far as tornado events in South Florida during the dry season, certainly much less numerous during a La Nina event. Even the weak La Nina events have a much lower number of tornadoes in South Florida than what we observed during the opposite, a strong El Nino, for example. So again, exemplifying what we talked about earlier. Go to the next slide. The typical January, February, March temperature distribution. This is for the South Florida area. These boxes kind of break it down into the different phases: El Nino on the left, neutral in the middle, and La Nina on the right. You can see the temperatures tend to be, or on average, higher during La Nina and as well as the neutral phase, especially compared to the El Nino phase on the left. Now, the next slide will kind of support that by showing you what has actually been observed in all the previous La Nina events when we take into account all the previous La Nina events over the last 70 years plus what the trends have been. In other words, what we've seen over the last 10 to 15 years. So when you add the two up, we end up with a 40 to 50% frequency of warmer than normal conditions during the La Nina winter in Florida, especially South Florida, more than any other possible event. If we looked at all the possibilities, there is a tilt towards warmer than normal conditions. Now, if we look at the precipitation side, go to the next slide here. There should be the same thing, but we're gonna switch over to precipitation. You'll see that La Nina is much drier. You see much lower rainfall amounts. The very stark difference here, contrast between the El Nino winters that are wetter, neutral is kind of in the middle, and La Nina is way on the dry side. So you can kind of get a sense here that the precipitation signals are much more defined in these type of patterns than the temperature patterns. And the next slide will show you the composite of all the La Nina events plus the recent trends and their frequencies. So for here, we have a greater than 70% frequency of drier than normal conditions during La Nina winter. So again, greater confidence in drier than normal rainfall or drier than normal precipitation during the La Nina events. Okay, next slide. These show three different models, or at least on composites. And again, these are basically support for precipitation, at least, the conditions that we just talked about. So these models are showing both drier, an increased likelihood of drier than normal conditions over the southern tier of the United States, including Florida. Okay, next slide. So here's where I start to caution people, including myself, to not get too tied down to that there's only one possibility here. You know, that it's, yes, it's absolutely going to be drier than normal, and it's going to be warmer than normal. These outlooks show the most likely outcome. So this map I showed earlier, this is the most likely outcome, but it's not the only possible outcome. If you go to the next slide, if you advance, you'll see a text pop up on the right side there. So these maps only show the most likely outcome where there's greater confidence, but it's not the only possible outcome. And these pie charts on the next slide do a pretty good job of describing that. So for example, for the time period December to February, for the 4 main airport sites in South Florida, basically, if you see the breakdown of above normal in red, below normal in blue, and near normal in white. So yes, there is a higher probability of above normal, but the probabilities of below and near are, you know, around 30%. So it's not a slam dunk, at least from a temperature standpoint, that it's going to be above normal. There's an increased likelihood, certainly. And if you go to the next slide, it's the same pie charts, but now we're switching the months to show January to March. So actually, if you look at January to March, the chances of above normal temperatures increase. So we're actually now well above or above 50% for above normal, and the below normal will actually go down to less than 20%. Unfortunately, they don't produce these pie charts for precipitation, because if we had them, you would see I would suspect that you would see a pretty stark, it would clearly show the high probabilities of drier than normal, given that precipitation, we have they're stronger signals than the temperature signals. Okay, go to the next slide. We'll talk about some other caveats that we see and deal with every winter, every dry season. There you go. So we have intra-seasonal cycles. We have the Arctic oscillation and North Atlantic oscillation, where those are the main ones that tend to affect North America during the winter. There's also other ones like the PNA and the MJO, and they can sometimes dominate the pattern when the ENSO phase isn't very defined. This year, I think La Nina is going to be pretty well defined, so that might mute in some sense some of these cycles, but not entirely. The problem here is that we really can't predict with any reliability these intra-seasonal cycles really more than 2 weeks in advance. So, if we could, that would be another piece of the puzzle that we'd be able to put in. Unfortunately, we can't do that. Just because, again, these cycles are not really reliably predictable beyond 2 weeks. So sometimes we end up getting conflicting or overriding signals. Give you an example. December of 2010. I don't know, some of you were, those of you that were here in Florida back then, you may remember that was a really cold December all across really the entire Southeast US and Florida. Actually, it was the coldest December on record for every station in Florida, all the way from Pensacola to Key West. That occurred during a strong La Nina. Believe it or not, right? Not supposed to be cold for long periods of time during La Nina, but it was, at least for that one December in 2010. So again, this is an example of where you can have brief fluctuations that can make a big difference, at least in a shorter term. So if you go to the next slide, without getting into a whole lot of detail, of these intraseasonal cycles, the one that tends to have the biggest impact is the North Atlantic Oscillation, which, along with its close relative, the Arctic Oscillation. These really, what it is, these are pressure differences between the North Atlantic or the far North Atlantic and the subtropical Atlantic. So depending on which phase we're in, whether the North Atlantic is lower pressures than normal compared to the subtropical Atlantic, that has a tendency to at least temporarily modify the position of the jet stream, which is really the main driver for the storm systems moving across the continent, as well as fluxes of fluxes of cold and warm air on either side of those jet streams. So when we're in what we call the negative North Atlantic Oscillation, or NAO, that's when the jet stream tends to shift farther south and we get greater chances of cold air intrusions all the way down to Florida. So if you go to the next slide, they kind of graphically show what these two different phases. So the North Atlantic Oscillation has been shown to have an impact on winter temperatures across really a large part of the country, especially here in Florida. So even if we're in a La Nina, overall La Nina conditions, December 2010, however, we were in a strongly negative North Atlantic Oscillation phase. So we ended up with a very cold pattern, cold temperatures, despite besides the large scale La Nina, which would tell you it shouldn't be cold. Well, the North Atlantic Oscillation, at least for a period of a few weeks, overrode the La Nina signal. And this can happen. This can happen any winter, and we can't predict really beyond 2 weeks whether this is going to happen or not. So that's why one of the most important caveats to these outlooks. Okay, good. Next slide. It kind of shows you how the North Atlantic Oscillation has kind of how the phases have kind of evolved over the last 70 years, going back to 1950. The red bars show years or winters where it's been positive, and the aqua color when it's been negative. So you see over the last, really for most of the last 30 years, we've been in a positive Arctic Oscillation. Again, Arctic Oscillation and North Atlantic Oscillation are similar. So that, again, the positive phases favor warmer than normal temperatures over the southern US. The negative favor colder than normal. So, you see the 2010, you see the big dip there. That was that December 2010 timeframe we just talked about. But the last several winters have been pretty warm here across Florida, and it's kind of coincided with the increasing number of positive cycles of this Arctic Oscillation. Okay, so we go to the next slide now. We're going to get just to dive in a little bit more into the outlook before we wrap up here, at least before I pass it over. And so everything that we've talked about so far. So again, the outlook for the November to April period, basically the bulk of the dry season, we we're calling for above normal temperatures, and that's a probable range. I don't really give that with a high level of confidence, but if you average the temperatures for each month, on average, will probably be somewhere around 1 to 3, maybe 1 to 3 above degrees Fahrenheit above normal. For precipitation, a little better confidence there, in the range of maybe 60 to 75% of normal. And again, this is for the period November to April. And below normal storm events, or below normal storminess, if you will. Now, for freeze, you would think, well, if we're calling for above normal temperatures, why is the freeze probability near normal? Well, one thing that we've seen is that even in La Nina winters, when we do get a break in the pattern and the cold air masses can actually go far or penetrate farther south, we can get some pretty cold outbreaks, temporary, of course, but can occur even during an overall warm winter. So for freeze, we're really saying it's probably about a near normal, which is about 1 to 2 events per season. And then the last one goes hand in hand with precipitation, and it's drought and wildfires. So because of the increased likelihood and pretty high confidence of below normal precipitation, the drought and wildfire development will be above normal, certainly, especially as we get into the latter half of the dry season, the February to April timeframe. So the next slide shows you the confidence levels for each one of these. So basically for precipitation, moderate to high. I mean, I could go high, but I've seen too many of these outlooks. I've seen too many of these patterns change. So don't want to be too confident when we're talking about a 6-month outlook here. So moderate to high is a reflection that, the signals are definitely pointing in that direction. Same for the storminess being below normal. And that also applies to the moderate to severe drought development. So when there's a moderate to high level of confidence that will end up at some point, maybe later in the dry season, end up with some moderate or even severe drought conditions. On the temperature side, the confidence is really no more than moderate. As we've seen, the temperature signals aren't quite as defined, but still there is a tendency, and the tendency is for warmer than normal temperatures, on average through the dry season. Okay, next slide. Again, just another reminder: the outlooks are, by definition, a general big picture view of a set of conditions that will probably exist. That's straight from Merriam-Webster. Go to the advanced, these outlooks, they're associated with definitely a large degree of uncertainty, especially when we get down to specifics, day-to-day specifics, certainly. And these are average conditions over the course of an entire season, and definitely not representative of what we expect every day or every week. There will be week-to-week fluctuations. Sometimes in winter, these fluctuations can be pretty dramatic. And again, sometimes even month to month. Sometimes these cycles can linger a little bit longer than just week to week. So again, we need to watch out for that. So all in all, these outlooks are good for general planning and overall awareness. It's hard to make specific day-to-day or week-to-week plans based on these. In fact, it's impossible to. So as far as potential impacts, well, with a drier than normal winter and dry season, that means that there's a probability or possibility of extended dry periods, which again can lead to drought conditions, which of course affect water supply. And that also increases the threat of wildfires, especially during the latter half of the dry season, February, March, and April, and even into May. Now, less Arctic air intrusions. We should go back one more. There you go. But since, let's say we end up with a overall warm winter, but then we get a couple of shots of really cold air, that actually can make crops even more sensitive, since they're acclimated to the warm conditions, and then all of a sudden we get a shot of cold air or a couple of shots of pretty cold Arctic air, and all of a sudden we're dealing with some significant issues with agriculture, as well as with people too. You can't ignore that as well. So as far as other, the time frames when some of these impacts occur, typically, we have rip currents, which are really, they can be present year round, but most favored during the early part of the season. And then again, once we get to March and April, we start getting an increase in rip currents and people also being in the water. So we have to watch out for that. The greatest time, or the time frame of most favorite time frame for freeze and cold impacts, are December to February, our winter months, obviously. Severe weather tends to be towards a little bit later, February to April, and then that's also the similar time frame for wildfires and droughts. Okay, that wraps it up for me. Thank you again. Thank you for your patience with the webinar today. And now I'm going to pass it over to Akin Owosina from the South Florida Water Management District. As he's done for the last couple of years, he's going to talk about the dry season outlook from the South Florida Water Management District perspective. So take it away, Akin.
Thanks, Robert. My name's Akin Owosina, and I'll be giving you a quick water condition summary and how the water management districts using the dry season outlook in part of our planning over the next upcoming dry season and the year to follow.
Can't hear him again.
I'm going to kind of go through some slides to kind of move us along quickly. First, I'm with the water management district, like I mentioned, where the largest of the 5 water management districts in South Florida. In Florida, we're located in South Florida from Orlando to the Keys. We cover about a 16-county area, serve a population of a little over 8 million residents. And within that region, our mission is to safeguard and restore the water resources, protect the communities from flooding, and meet the region's water needs, while doing this in a very public way with our stakeholders. We manage more than 2,000 miles of canals, more than 2,000 miles of levees, several structures, pump stations, and lots of storage areas to meet those mission elements I mentioned earlier. And some of the things I'll be focusing on today is the status of some of those storage areas and how we are set up going into a dry season that, as Robert so well described, could potentially be drier than normal. First, our system is mostly rainfall driven, and one of the first things I'd like to share with you is this chart we use with our governing board for briefings, and it shows the historic rainfall, the rainfall that was received over the last essentially 2 years in this case. And any cases where you see the reds, it shows that that month was in deficit relative to the long-term average, and where you see the darker blue shows that that month was a surplus relative to the long-term average. And I'd like you to key on the wet season, the last several months in this bar chart. And we've had an oscillation between a little bit drier and a little bit wetter, but we're ending on a wetter note. And October is already a surplus over what we historically get in Octobers. The same information is summarized now spatially. The last chart I showed you district-wide. This chart is showing you the same information, but distributed across the footprint of the district. And the image to your left is looking purely at the month of September, 2020 September, which is the last complete month. And the key takeaway from that was we ended up with a surplus. Things are wetter. If you saw the same chart for October, it will also be greens all over, meaning that we again would have a surplus over the long-term average. And for the chart to your right, what you're looking at is the entire wet season setup. And we could see that for this year, we came in again with a surplus over the long-term average, in excess of 7 inches, actually, over the long-term average. Some areas were wetter than others, but the entire part of our system got more than average rainfall overall. So going north to south, I'll start from the upper part of the system. And what the key takeaway I want you to have from this slide is an understanding of what our schedules mean. We operate the systems, the part of the systems, using schedules developed by the U.S. Army Corps of Engineers. And the red line on each of those charts that you see represents the top of the schedule. When we go above that, we operate the system to try to bring the lakes, the level of those lakes down so that they're at schedule or slightly below schedule. The way these schedules are set up, as we approach the winter, we want to allow more and more water in the lakes so that we'll go into the dry season with the lakes as full as we can let them be while maintaining the flood control within the region. And so you'll notice that in each of these cases, the schedule have what we call a winter pool elevation, which is on the high end. And as you look at the current conditions, what you see in each of these traces are the water levels within those lakes, either following the schedule up towards the winter pool elevation, or already on a high side and going sideways to try to intersect the winter pool elevation. Robert was so kind to mention earlier that we're not done with the rain season yet, and the hurricane season isn't over. We could end up with an event, hope we don't, knock on wood, that throws up much higher than where we are. But with the way things are, the upper part of our system, we're tracking nicely, and we think that going into the dry season, we will be right about where we'd like to be at the top of the schedule at that winter pool elevation. Now, as I move down into Lake Okeechobee, I'm going to kind of spend a little bit of time on the lake. Lake Okeechobee is the liquid heart of Florida, is the way it's been described. It's the center of our system, and it really dictates what water supply condition is most of the rest of the year. I'm going to show you a number of these very busy plots, but I'm going to spread it across several that I'll use to explain what you're looking at. But what you're looking at here, the blue trace, is the current year, and the circle in that blue trace shows where we are today. The other traces are different years in the past, just randomly selected years that shows you how the system, how the lake has responded based on the weather, what we actually observed by way of rainfall. And the next chart that you're looking at here, which looks even busier, is the same thing, the current level of Lake Okeechobee, but with a selection of years where we were in conditions similar to this year, where we're anticipating La Nina conditions or a drier than normal dry season. And part of the reason I'm showing this is to show you that strange things happen in the dry season. Sometimes we get some rain, sometimes it gets dry, but looking at this subset of years when we were looking at conditions similar to this year with regards to the La Nina, not the North Atlantic Oscillation or any other thing. These are some samples of how the lake has responded going forward. Now, this is important not only for the immediate dry season, but for the wet season and dry season to follow. We found out that our system has some memory, and how we transition out of this coming dry season sets us up for the next wet season and then the dry season after that. And historically, and I'll show you with some of the slides, if we come out at a good level at the end of the coming dry season and we have a dry wet season, we could still be in a situation that's uncomfortably low in the lake the year after. So we have to think more than one season out. We're thinking a year and a half or two out. This first chart that I'm showing shows the 2000-2001 year compared to now, and essentially shows that we started those 2 years lower than what we are this year, and we ended up with a dry season that was predicted to be low and that was low, and essentially took us into one of the driest conditions we've had in the lake in many years. I think it was only topped by the conditions we saw in 2007. You could see that by June of the 2001 year, that the lake was down to elevation 9 feet, which is really low. This one chart shows 3 years, and I think this tells a story that I'd like people to think about. We started 2006 fairly wet, and the dry season of that year was relatively dry. The wet season didn't materialize more, so we got into the dry season of 2006 with a somewhat lower lake level than we'd like to be, not like this year. And then we got the dry season, the drought that followed, and it took the water levels to the lowest level we'd seen in 2007. We came out of that wet season low again, and we started the next year even lower than we started 2007. And we were extremely worried as a district for the people who were tracking what we were doing at that time. But that dry season wasn't as dry as normal. It ended up being a little bit wetter than normal. We didn't get as low in 2008 as we did in 2007. And then you'll see the big bump in the August, September area. I think that was probably Faye, Tropical Storm Faye. And the lake level rose, and we got out of that condition that was extremely precarious for water supply during this cycle. This last set that I will use essentially shows a similar period. This was 2010, 2011. Robert mentioned this because we had the North Atlantic Oscillation overriding the La Nina type effects. And the way that shows up in the chart that you're looking at was we went into the dry season at a low level, but we didn't get as low as we did in some of the earlier years, even though things were still relatively dry, especially because if you look in that December, January timeframe, things were still wetter than they would have been had we been warmer and drier, as La Nina would have dictated. So this is a setup for the current dry season. The blue line is a happy place to be. I think the system is full. It's high within the lake. Unfortunately, it's a little bit too high. We're having discharges to the estuaries, which is undesirable, but the lake is set up nicely for essentially going into a dry season. One of the tools we use, and I'll kind of spend a little bit of time on this, one of the tools we use is what we call the dynamic position analysis. We look at the historic record and we use our numerical models to simulate from the date. We do this on a monthly basis. We could do more frequently if we need to, but we simulate from a particular date in time, usually the start of a month, and we look at how the system might respond. And the way to interpret this is that the shaded section in the middle, between the 25th and the 75th percentile, tells us that we have a 50-50 chance that the lake level will be within that space. And I want you to take two things. Take a look at the June 1st date. And that's the level when we assume we're coming out of the dry season. And we look very carefully at that date to try to see where we think we might be, and if we're going to be at a risk of going into the wet season with conditions that could result in maybe having to set up a water shortage. But anyway, looking at the June 1 for this, the good chances are good that we'll be in a good place with the current lake level on June 1. Now, there are extremes that we've observed that take us to low elevations on June 1, but right now, the way we're set up, it looks like we'll be in a good chance of being at a reasonable good lake level come June 1 of next year. Robert talked about La Nina extensively. So the middle bullet is what I'd like you to just take away from this particular slide, that during La Nina conditions, we anticipate drier than normal dry season. And so what I've done here is looking at the dynamic position analysis and selecting the La Nina sample years alone. I've shown what you might see in some of the potential La Nina years. And what I want you to take away from this chart is take a look at that blue trace, the blue traces. Starting from a high lake level, there's still the possibility that we could run the lake really low, depending on how dry this year is. But if you stay on that blue trace, you'll notice that from July through August on that 1 year, even though we got really, really low, the wet season started with a bang and things recovered rather quickly. So looking at the rest of the system, as we have the conditions in the north of the lake and the lake itself, what this shows you is the schedule for the water conservation areas which are south of the lake. And what I want you to take away from this graphic is the location of the blue and green trace relative to the red line. The red line is the top of the schedule. We try to operate below or at that schedule. What you'll see is that in every single water conservation areas, we are at or above schedule, which means they are full. And the way that the traffic light graphic in the middle, you see a lot of red lights are showing in the middle part of the system. And what this is telling you is that those systems are full and we can't send water to them right now from Lake Okeechobee. So again, from the point of view of flood control, this is typically a scary thing. I'm glad we're not here at the start of the wet season, but going into a potentially drier than normal dry season, we couldn't be set up better for where we are with regards to water. Now, obviously, we still have concerns for the last couple of weeks, and hopefully the dry period does materialize, and we can lower the levels within these water bodies to fall below the winter pools for these systems also. Again, Robert mentioned the outlook. We take a look at the long-term projections. As he noted, these are the most likely occurrences. It doesn't mean that for sure this is what will happen. It just shows that there's a more likely than normal condition that you will be drier than normal going forward. And so that's certainly one of the things we consider. And when you look at the November to January timeframe and the December through February time frame, there is a much stronger signal suggesting that things will be much drier than normal. And so we're set up well for those, and I think we'll be able to manage the storage that we have in place through the dry season this year. Now, we also use some of the shorter time outlooks from a meteorologist, and while this represents the current time, it's not relevant for the longer time periods, but I'm just sharing this to let you know that as we go through on a week-by-week basis, we get the quantitative precipitation forecast from a meteorologist, and we couple this with the long-term forecast, the state of the system, to make operational decisions on a day-by-day basis, sometimes at a smaller level than a day-by-day, as we go through the dry season, with the goal being to manage the water resources of the region to meet the overall objectives: water supply for the environment, for restoration, water supply for agriculture, water supply for drinking water sources, and the conditions of the lake Okeechobee itself, which is actually a natural water body and has some ecological needs. So what are the specific operations that we implement in the next several months as we enter into the dry season? This is an opportunity to test our forward pumps, the pumps that we use to assist in sending water out of the system. And so we test all of those pumps, make sure that they're operational and ready to go as we get into the dry season. We take the opportunity of the dry conditions to schedule maintenance and upgrade activities to the water control system. We typically switch our operations from flood control objectives or strategies to water conserving strategies. We take a canal system and we operate them at the higher part of their operational range, in part to hold on to water, to minimize the need for pumping for water supply by elevating the water table, to minimize irrigation use in the urban areas, but also, and very importantly, to keep the canal elevations high enough to keep the water tables elevated to mitigate against saltwater intrusion, which will tend to want to move inland around this time of the year as water tables drop normally. We obviously track rainfall accumulations and projections, as I mentioned earlier, to use that to guide operations. And we essentially make operational decisions at this point to try to manage the water we have in storage to make it last right through the year. Ideally, we'll end the year with our storage near to empty, not fully empty, because we need to think about that next year out. But we operate the system at this point to make sure that we create room in our storage systems for the next rainy season and have a place to store water when those rains do arrive. And so those are the slides that I have to share today. I'm sure both Robert and I will be glad to take questions if you have any.
All right, thank you very much, Akin. Hopefully you can hear me. So yeah, I think now let's go ahead and open up the floor for questions. I think the way we're going to do it is there's a feature on Zoom where you can raise your hand. That way we know that you have a question, and then you'll be unmuted and you'll be able to ask your question. So we'll go ahead and start with that process now.
Thank you, gentlemen.
Oh, thank you. Okay, any questions? The floor is open. or as open as it could be virtually, I guess.
Excuse me, sir, the chat is disabled, so I'm not sure if anyone could type in a question.
Okay, well, if yeah, okay, if you have a question, I think either I think you can just signal or raise your hand. I know that there's a feature that you can use on Zoom that you can alert someone that you want to speak. I think that's the way I think we're handling this.
Thank you.
Thank you.
Hey, Robert, can you hear me? It's Kim Miller.
Yes, I can. I can hear you.
Hi. I don't know where the raise hands feature is, but I have a question. You had said that even though technically we entered, the dry season October 15th, that we still really haven't made the weather shift or the climate shift there. Do you see that happening in the next couple of weeks or this weekend?
There are some indications, at least in the longer term, like close to a week in time, that we could have a cold front could be moving through the area. We're talking early next week. If that trend holds, then maybe that could, and I don't want to say will, it could signal the real beginning of the beginning of the actual drier pattern. Or maybe it's the case where the transition period is just being shifted, later in time. Right now, obviously right now we're still not in that transition period yet, or it's very slow to get into. But it does look like it's probably a better chance that next week will at least be more into the transition period, where we will probably see at least some, a tendency towards drier, less humid, more stable atmospheric conditions. But we'll have to wait and see till we get a better sense of that over the coming days.
Thank you.
Thank you. And I believe if you have a question, maybe you can just go ahead and speak. I don't know if the feature is working, the raise hand feature. You can just speak if you have a question. Hopefully that works. Okay.
Well,
Thank you very much, Josh.
I have another question. It's Kim again.
Yes. Yes.
Robert, this is for Robert. Early on in your slideshow, you said that we've been abnormally warm the past 9 winters. Did I catch that right?
Well, warmer than normal.
Warmer than normal.
Just,
okay.
Yeah, correct.
And so if we do what the forecast is for this winter, it'll be the 10th year we're warmer than normal.
Yes, that's correct. The last winter in which we had below normal temperatures was 2010, 2011.
Oh. And then obviously follow-up question, sorry, how much of that do you think is tied to climate change?
Well, the background, I mean, so, if you consider, increase in global temperatures is sort of the background, right? Those temperatures that have increased. So, I mean, with that in mind, there is a contribution or from that, but it doesn't explain entirely, why we've had, 9 winters of above normal temperatures. There's other things going on as well. And it's really hard to pin down exactly what those are. There are probably many more factors than we're even aware of. I did show the North Atlantic oscillation phases. Those have tended to be mostly on the positive side over the last several years, really for most of the decade of the 2010s. So that could be a factor that at least we can kind of point to and make sense. But there are other factors as well. And to be honest with you, a lot of factors that we probably haven't studied in full or don't fully understand.
Thank you.
Thank you.
Yeah, just so that everybody knows, you could use the chat feature now. It's been activated.
Robert?
Yes.
Will you be emailing those slides to us?
I have my slides, the ones that I showed at the beginning, and then Akin has his. Do I assume that you're going to want the whole set?
Yes.
Okay. Okay. Yeah. Okay. Well, yeah. We'll coordinate afterwards after the presentation and make sure that we can do that, and we'll go ahead and make those
It's not
available.
a
You know,
problem.
if we can get them together. Yeah. Thank you.
Okay, thanks.
All right. I'm monitoring the chat here to see if anyone has any questions via the chat, but you can also just go ahead and talk. I think that works as well. Okay. Any additional questions? Okay. Yeah, I want to allow a little bit of time, for the, since we're doing this virtually, for someone to maybe unmute their phones or unmute their computers. Okay, well, maybe it looks like we're done here. Again, one last chance. Are there any questions before we wrap it up? All right. All right, well, I want to thank everyone. First of all, I want to apologize for the delay. And I also want to thank everyone for hanging in there, despite the late start. I think the partnership with South Florida Water Management District for these outlooks exemplifies really the main, really how these outlooks are applied. They're applied for planning purposes, and I think Akin described that really well. The process that they use at the district, based on current conditions and what we think will evolve or occur over the next several months. So once again, I thank everyone for your participation, and then we'll see if we can get those slides out here before the day is done. So anything, Akin, on your end that you want to say before you wrap up?
I just want to thank everybody for attending, and we certainly will make the slides available. And if there's a follow-on question, if you get us through Robert, we'll be glad to respond. Thank you.
All right. Thank you very much, everyone, and have a great day. Take care.
Thank you, gentlemen.
Bye, thank you.
Thank you.